Do you ever hear about pork gelatin? I am sure that all of you already know that product sourced from pork and its derivatives are prohibited for Muslims. So, hi, Assalamu alaikum. Today we would like to talk about a rapid ATR-FTIR spectroscopic method for classification of gelatin gummy candies in relation to the gelatin source. This topic is taken from the journal published by Food Chemistry with 8.8 impact factor. So, here is team members consists of Nurin Fatihah, Nur Ardini and Nurul BAlqis. In this presentation, we would like to start with introduction and followed by objective and method, result and discussion, and lastly with conclusion. In general, gelatin is a thermal hydrolysis product of collagen from cattle bones, cattle hides, and pork skins, which used as scaling, thickening, and stabilizing agents. Gelatin also used as texturization, emulsification, and adhesiveness. The gelatin occurs in a wide variety of foodstuffs, such as gummy candies, jellies, and marshmallows. Porcine and bovine gelatins are mainly produced, exports, and imports to around the world due to demand, especially confectionery industry. Most of commercial gelatin are extracted from pig skins, bones, and other sources. Up to now, PCR, electrophoretic, chromatography, and spectroscopic techniques were performed in order to detect the source of gelatin. Those methods have disadvantages, which is time-consuming and destructive. So, FTIR method can be non-destructively and rapidly used to obtain biochemical fingerprints that will provide information and molecular structure and composition. In this study, FTIR-ATR method was built, which is a new, rapid, effective, and cost-effective method. The chemometric or HTA, PCA were performed to process FTIR data.
Hi, my name is Nur Fatihah binti Ahmad Farizal. My metric number is 2023379723. I will continue this presentation with objective and method. So the first one is objective. There are two objectives in this experiment, which is this study aims to use laboratory-made gummy candies as a standard to analyze the gelatin composition of commercial gummy candies through spectral analysis. And the second objective is to determine the accuracy and reliability of the results by using the FTIR, ATR, and RT-PCR. The first method is material and reagents. FTIR or NIR spectrometer with a caviar pin splitter, DTGS detector, and 3 bonds ATR accessory with a diamond crystal is the study that has been used, which is the study used is from Perkin-Elmer Frontiers method. Standard bovine and porcine gelatin were used to prepare gummy candy samples. They were made with a 3-sugar composition, which is sucrose and glucose, sucrose and maltose, and the third one is sucrose and fructose. These 3 compositions is to increase the diversity. The conversion product, which is pectin and citric acid, were obtained from Smart Kimia from Turkey. The ethanol and water is obtained from Sigma Eldridge, and 20 samples of gummy candies were used in this method, which is the sample were purchased from the market in Turkey and abroad. This is the table which the ingredients of each gummy candy sample produced in laboratory. The second method is production of gummy candies. The basis of the recipe of Herbsters and Fox 2004 were used to obtain film of 30 gummy candies in the laboratory. Next, 7 grams of pectin, 330 grams of sucrose, 480 grams of glucose syrup, 320 grams of water, 3 grams of gelatin savoring, 20 ml or 50% of citric acid were used in this production of gummies. The citric acid in this experiment was used to adjust the value of pH. The gelatin was swirled with the water and stirred on a magnetic stirrer until it completely dissolved in the water. The pectin was mixed with the 100 grams of sucrose. This mixture of pectin and sucrose was stirred with 200 grams of water and it has been boiled while stirring it until it dissolved. Next, when the mixture has been dissolved, sucrose and glucose syrup was added and the mix has been cooked. Glucose, fructose, and maltose has been used for each gelatin to increase the sample diversity. After the gelatin was dissolved, the color and flavor was added in the mixture of pectin and sucrose and make sure the pH value is nearly 3.2 until 3.4. The citric acid has been used to adjust the pH value. 3 samples of combination gelatin and sugars were prepared, which is the first combination is sucrose and fructose, sucrose and glucose, and the last one is sucrose and maltose. Sucrose has been used in all combinations, included in all lab-produced gummy candies. The third method is spectral activation. 8 cm -1 is the resolution that has been used for all samples in FTIR-ATR, averaging 16 scans per spectrum. Spectral measurement were conducted across the mid-infrared range from 4000 to 650 cm -1. Triplicate measurements were performed using a diamond triple bond ATR accessory, and the average spectrum from the triplicate analysis was obtained. A background S spectrum was collected and the samples were directly compressed onto attenuate total reflectance, which is ATR crystal without any preparation. The last one is the diamond crystal was cleaned using ethanol and distilled water. Next is the chemometric, which is HCA and PCA. HCA is the hierarchical cluster analysis and PCA is the principal component analysis. The both of these chemometric has been used with FTIR. The purpose of use this both HCA and PCA is to classify the investigated materials in gummy candies, and ALQis version 7.2 software was used for the classification. In the HCA, all spectra were pre-processed by generating first derivative spectra with 25 floating point Watts algorithm. Algorithm normal to Vipro level was selected and separated for each frequency range. PCA generated 2D and 3D core plot, and the classification model included first derivative and vector normality, which is also 25 smoothing versions of all spectra. This experiment has been used another algorithm such as single and complete linkage to discriminate gummy candies based on their gelatin source.
Assalamualaikum, my name is Nur Ardini, and for result, the first spectrum below is to show the three types of jelly candy that has been produced in the lab. For the first one, it used sucrose plus fructose, the second one is sucrose plus glucose, and the third one is sucrose plus maltose. The second spectrum is to compare between the jelly gummy that has been produced in the lab and the jelly gummy that has been buy at the market. The spectrum was observed and has been classified into this table. And for the discussion, the spectrum of gummy candy that has been produced in the lab has almost the same spectrum with the jelly gummy that has been purchased from the market. The most significant band, which is wave number that related to gelatin, was observed in 1700 and 1600. The result provided show that all the three jelly gummy produced has a wave number between 1643, 1645 and 1649, which included in the amide spectrum range. Lab-produced gummy can be used as a sample to compare the type of gelatin used in the purchased gummy candy. So, further tests has been made using the hierarchical cluster analysis, principal component analysis, and polymerase chain reaction. Test was used to identify type of gelatin, either using porcine or bovine gelatin. The importance of analyzing the analyte from the sample, which is to know the presence of what the analytes that we want. For example, in these cases, we compare the FTIR spectrum of lab-produced jelly gummy with the market jelly gummy. It showed that the spectrum obtained containing amide C double bond O that usually refer to the presence of gelatin in the gummy jelly. The gelatin is that used to compare between porcine and bovine using PCR and other advanced instruments. Why FTIR method was chosen compared with another method, which is because FTIR is a non-destructive analysis. It has speed and efficiency, minimal sample preparation, and also comprehensive molecular information. The limitation of using FTIR, which is FTIR has limited sensitivity. It is sensitive to sample interference. It has complex mixture and also the quantitative limitation.
Lastly, conclusion. Gummy candy samples could be perfectly distinguished in terms of their gelatin source. The class prediction of gummy candies were performed with 100% correct classification. The identification of all the samples by FTIR-ATR technique was confirmed using PCR technique with 100% accuracy without any disarrangements or false prediction. Discrimination and classification of gummy candies on the basis of their gelatin source were successfully performed by FTIR-ATR without sample preparation. Due to its advantages, which is rapid, easy to operate, non-destructive, FTIR-ATR can be mentioned as green analytical technique. In order to complete this task, here are references that we use. So that's all from us. Thank you.